I'm Anna Hoffman, and welcome to this episode of Data Exposed Live. We are super excited to have you joining us today from wherever you're joining from, whether it's Learn TV, Twitch, Twitter, YouTube, wherever it is that you're streaming from. We're happy to have you here today. I just want to remind you all that we are looking at questions throughout the whole session. So if at any point you have a question, a comment, you think something's cool, anything you want to say to myself or our other presenters, please engage with us. It makes it more fun. It breaks up the talk, and we love to hear and see your comments. So that being said, I wanted to go ahead and get started today. We are going to be continuing our Azure SQL Security Series. And without further ado, I'm going to bring up our main presenter of the day, Rohit. Hey, Rohit, how's it going?
Good morning, Anna. I'm doing well. Thank you for having me.
Yeah, it's a pleasure to have you. You know, we've done some stuff, but it's been a while. Before we get started, I'd love if you could just give our viewers a little bit of an introduction about what you do.
Absolutely. Everyone, my name is Rohit Nayak. I'm a program manager here on the Azure SQL Database team, and I deal with network security and connectivity scenarios for Azure SQL.
Awesome, great. And it seems like for our topic today, network security, you're like the perfect candidate for us to have on the show. So thanks so much for joining us. For people who are just joining us for the first time, or maybe have been following this series, I wanted to give folks a recap on what we've talked about so far. So in this series, this is the Azure SQL Security Series. We've been streaming about once every 2 months. You can hit that URL at the bottom of your page there to find all the episodes. And if we just go through the past episodes, the first episode we had Joachim on, and he kind of gave us an overview of all the different security pillars. Rohit, if you don't mind showing all the security pillars. So Joachim came on, did a great job, great show with some demos on that. Then we had Murik and Andreas on to talk about authentication and access management. So this is a big topic. And the next time we had Jason, Shoham, and Jakob come on to talk about all sorts of cool stuff around data protection, including things like always encrypted with secure enclaves and SQL Ledger. So some exciting episodes have happened already. So definitely check out our series. But Rohit, can you tell us a little bit more about what we're going to be talking about today?
Yes, Anna. So today's talk is all about understanding basics of how connectivity works for Azure SQL Database. And we'll start by looking at some connectivity architecture and network access controls. And then we will pivot to what's called as VNET integration patterns, which is nothing but private connectivity. And then we'll end today's episode by looking at some cool upcoming features. My target here is mainly for beginners who are new to Azure SQL. But at the same time, my hope is that even long-time users walk away with a better understanding of the internals. And while we'll be going through the choices that you have for network security, my hope is you'll end up learning what choice makes the best sense for your production workload. So that's our aim for today.
Awesome. Let's get started.
Awesome. So with that, we'll dive into our first section, which is all around understanding connectivity to Azure SQL. And what I have here is just a diagram just showing you a region, say West US2. We have a shared control plane in each region, which we have multiple gateway machines, which are going to accept your incoming logins. And these are internet facing, and they have well-documented public IP addresses. And then in the backend, we are running SQL Server, which is where your SQL database is hosted. Now, when you as a client connect to your database.windows.net, which is your server, DNS resolution will resolve it to one of these SQL gateways and the port 1433. And that's how your connection will be made. So, and this mode of connection is called the proxy mode, where the gateway acts as a proxy in the middle, and not only your initial login attempt, but subsequent query results flow through the gateway. Now, there's a better way of connecting, which is called redirection, in which what happens is the client looks up does an initial lookup at the gateway, and it gets what is called as a redirection token, which looks something like this, which is an Azure IP address in the data center and a port in the range of 11,000 through 11,999, right? And then for all subsequent, like the login to the database and the queries, the client is talking directly to your SQL database in the backend. Now, one thing to call out is proxy versus redirection is something that you as a customer can set at the server level, and I'll show that to you in our demo. And then what happens is if you do not set anything, the default behavior is we will use proxy connection method when you are connecting from outside of Azure, and we will use redirection when we detect that your client is connecting from inside Azure.
Gotcha. No, it's definitely useful to understand how this connectivity works. One quick question I have, you mentioned the defaults, and the default for outside of Azure is proxy, but earlier you mentioned that redirect is kind of more efficient and it's better. So why don't we do redirect for everything by default?
We would love for our customers to do that, right? Redirect is the more efficient method because clearly the gateway is not in the middle anymore. However, we recognize that customers have constraints in their IT infrastructure where opening up that port range of 11,000 through 11,999 and also the Azure IP addresses may not be feasible. So that's why this is where the choice is in the customer's hands, where for chatty workloads, we definitely want them to use redirection, but if they cannot, then proxy is always the default way to go.
Got it. That makes sense. So people can change it later once they
Yes,
set up their ports correctly. Awesome.
absolutely. All right, so continuing on, let me talk about some recent improvements that we made in the connectivity area. And this has some important implications for connectivity as well. So here, similarly, from continuing from the previous slide, you have this gateways. And what we have done is we have grouped gateways into logical units called data slices. And then we use Azure Traffic Manager to load balance between those data slices. And you'll actually see this if you do a NS lookup on your server, right? You'll see the data slice and the traffic manager uh, in the path. So why is this important, right? So first thing is, for you as a customer, you need to know that there are these other components in the path that are there to help with increased availability. And because of which, what happens is you can no longer take a dependency on a single gateway IP address. So for example, on the screen here, I'm showing you we have multiple individual IP addresses per region, and these are documented. So that's why going forward, you should be able to reach all of them because that's how the traffic manager profile can load balance you. And then which brings me to another improvement that we made recently, which is in the past, what would happen is we would send customers service health notification whenever this list of individual IP addresses would change, whether if we are adding new IP addresses because we created new gateways based on better hardware, or whether we are removing IP addresses because older hardware needs to be taken out, right? We have now also added another column in our public docs called subnet ranges in each region. So what that means is there's a pre-allocated range of IP addresses for any new SQL gateways in the region. So this is an improvement that customers can take advantage of, and you just need to allow this subnet range instead of dealing with any notifications for new IP addresses being added to the region. So we are hoping customers leverage that a lot.
Awesome. Hey, Rohit, we had one quick question from the
Yes.
audience about the connectivity architecture.
Yes.
This person asked on YouTube, is the architecture the same for both SQL DB and MI?
Oh, awesome question, right? I mean, the fundamental moving blocks are the same. And as we'll see in the next section is how it is used or how it's deployed is slightly different. But yeah, the basic building blocks are the same.
Awesome. Thanks.
All right. So So far, we learned connectivity architecture. Let's talk about, how do you actually control which client can connect to your database, right? So these are the network access controls we have around public connectivity. The first one is this big button called allow access to Azure services. What this means is allow connection attempts from any clients that are inside the Azure boundary, regardless of which subscription or which region they are connecting from, right? And now usually customers shake their head and say, why do you even allow this? And there is good reason, because there are some scenarios where you do not have a well-defined or a static IP address for some services, like for example, Azure Data Factory, or even some of our own features like data sync and import export, right? So that's where you will need to set this button to on, but otherwise we recommend keeping it off. Now, as I'll talk about private connectivity, what is happening is most services and even our features are moving to private connectivity in the long run. So that's why you will see that less and less features need this button to be set to on in the as we progress. Right. Next, we have what are called as server level firewall rules. These are just IP based, which is in which you add the IP address for the client that you need connectivity from, and it just works. I want to call out here that the allow Azure services is a special type of IP-based firewall rules where the start and end IP address is all zeros, right? So you may see that in your DMVs, which I'll show next. Finally, we have VNET firewall rules. So these are, again, another type of firewall rules where you allow less traffic from a particular VNet and subnet. So for example, in the screen here, I have this VM subnet, which has a 10.0.0.32/27 address range. And all this means is I'm allowing all clients in that VNet to be able to connect, right? Now, the one thing that is not shown here on the screen, because it's not in the portal, is database level firewall rules. So similar to how you can define IP-based firewall rules at the server level, you can also define them at the database level if you want to have a smaller or a different range of IP addresses for an individual database. So now, let's briefly talk about how these various network access controls are evaluated. So for an incoming connection, the first thing we check is, do we have a match in the VNet firewall rules? Because clearly this is traffic that is coming from inside Azure from a subnet. So we want to prioritize that, right? And if a match is found, then yes, you have access to the entire server in the sense that you can connect to any database below the server. If not, then knowing that database level firewall rules are typically more tightly scoped, we check for those. And those are stored in sys.database firewall rules DMV in the master database. If we find a match, then you get a database scoped connection. So you can only connect to that specific database. And finally, we check all the server level firewall rules, which are stored in sys.firewall rules DMV in the master database. And if no connectivity, none of these match, then your connection is denied. Right? So that was our tour of public connectivity. And then I think the next section we want to go to is all about private connectivity. But before I do that, I want us to quickly have a very, very high level overview of Azure networking. This is, again, as I said, very high level, just so that for the folks who are very new to Azure, they have a basic grounding of what networking looks like, right? So when we are dealing with Azure networking, we have this concept of a virtual network. And a virtual network or a VNet is just a representation of your network in Azure. And typically, a VNet is represented by using this slash notation that you see. which is the slash is used for, it's called CIDR notation in networking, but all that it means is the slash 16 here means around 65,000 IP addresses from 0.0 to 255.255, as I've shown in this screen. Now, this is a huge range of IP addresses, right? So more than likely, I'm not going to use all of them at once. The way I will use them in practice is by carving out what are called as subnets. So you'll see I've carved out a front-end subnet here, and it is a /27, which equals 32 IP addresses. So I'll divide my virtual network into smaller subnets, and then I can basically connect to resources like, say, virtual machines or any PaaS service running, any service running in a subnet using either the internet, like by opening up specific ports. Say, for example, I want to remote desktop into my VM. I need to open up port 3389. Or the other way is I can set up connectivity to my on-premises infrastructure by using VPN or ExpressRoute. And to do this, I need to put a VPN gateway in the middle, right? So that was just our very high-level overview of Azure networking, which hopefully gives us a grounding to go into our next section, which is all about VNet integration patterns. Now, what does VNet integration mean? It means a way of how we run SQL Server in the context of a VNet that you own, you as in you, the customer.
Awesome. So this is where we'll dive into kind of the subtle differences between managed instance and database.
Yes, that's correct, Anna. So basically, uh, as I said, VNet integration is all about how we take our SQL Server code base and we run it in the context of a VNet that's owned by the customer. And the first attempt at doing that is called VNet injection. And this is exactly what managed instance did, is this blue bounding box I'm showing here is just a representation of a VNet that is owned by the customer. And then what we did was we took all these various components, and that goes back to the question that we got on the chat is, hey, we have these gateways and we have the backend nodes, and this is exactly the same architecture. It's just tweaked a little bit differently so that it runs within the context of the customer's VNet. And then since it's running within the VNet, then you get a private IP address for connecting to your managed instance. So that was the big paradigm shift here is instead of having this shared control plane, we give you all that goodness inside of a VNet, which you control.
Awesome. So we talked about this TDS endpoint. You said it's a private IP address. Does SQL DB have a private IP address?
That's a great segue into our next section, which is all about customers said, hey, this is great that you've done this for managed instance. I want this for Azure SQL Database.
Right.
And that is what led to this next VNet integration pattern of private link. And this is, again, a pattern that comes to us from the Azure networking team, whom we collaborate with very deeply. And what this is all about is offering private connectivity to any PaaS service from within the customer's VNet. And I'll illustrate how we do that by, let's just say you have a SQL database as it is running today, and you have your client, say you have this VM inside of a VNet that you want to be able to connect to SQL database. And say you're running SSMS or some client application on the VM. What this private link pattern does is basically takes another IP address from that same VNet and creates a private endpoint. So a private endpoint, think of it as nothing but creating a link between, that's why it's called private link. It creates a link between this VNet and the PaaS service. And as we'll see going forward, this PaaS service can be anything, like the list is growing, but what are the benefits of these, right? Why is this important? It's because for the VM that's running in the VNet, it doesn't know how it's connecting to SQL database, right? The connection string remains unchanged. Nothing changes from the client side. And you can enable several networking topologies that I'll show next that come for free as long as you do this private link pattern. And finally, as I said, it's GA for, it started with SQL database and storage, but right now you will see this pattern more and more being adopted by all PaaS services in Azure. Right? So let me, how do you say, peel the layers of the onion a little bit, talk more about what actually is a private endpoint, right? So at the very high level, it's just an IP address, but a little bit more than that. To create a private endpoint, you need three things. Number one is, what is the private link resource, which means like, what is the PaaS service that you're connecting to? Is it a storage account? Is it SQL database? What have you? Next, what is where will this be created? Which is, give me the VNet and the subnet where I can get this IP address from. And then the third thing is the private DNS zone. So this is an interesting concept because this is the magic sauce that makes sure that when you try to connect to your logical server, that connection goes through that private endpoint. Right? And I'll briefly talk about the various ways in which you can enable connectivity to the private endpoint here. So you can have a client that's in the same VNet. This is pretty straightforward. You can have VNet peering, where you can have a peered VNet uh, under the same subscription, and then this just works seamlessly. You can add a VNet gateway into your current VNet, and that enables a couple of interesting scenarios, like you can connect from on-premises, or you can connect from another VNet using a VNet to VNet connection. So this is typically used when you're going like cross-subscription or cross-region. But the key takeaway from this slide is all this is given to you by Azure Networking today. And by using a private endpoint, you can enable these various ways of connecting, right? So we talked about public connectivity. We talked about private connectivity. Now, at this point, let me introduce a couple of connectivity settings we added at the server level that brings that story together. So the first one is this setting called deny public network access, and it does exactly as it is spelled out, right? I mean, it basically, the use case is you have decided your private link works for you, private connectivity, everything works. You want to close all public connectivity, which means nobody can connect by adding an IP address in the firewall rules. This is the button to turn that off. Other one that we worked on is this is more relevant to security, which is a minimal TLS version, which means if you do choose to set one of the versions here, say for example, I set TLS 1.1, then uh, TLS 1.0 will be disabled, but I can use 1.1 and 1.2. So that's how this setting works.
Gotcha. This is interesting. And I'm guessing these are kind of the defaults. What's interesting to me here is there's no, or at least it looks like there's no default minimum TLS version. Why is that?
That's correct. And this is because we recognize that our customers use a broad set of legacy applications and drivers to connect to Azure SQL. So that's why we do not want to make the decision for them, because if I do enforce TLS 1.2, I might break some customer's application or service. So that's why we want to leave the choice over to the customer as to which version works best for their client applications, and then they can come set it at this point.
Gotcha. That makes sense. And especially for like people who are migrating, maybe they have legacy apps, they might need this.
Yes. I think we are right on time for demo time. All right. So now I've been speaking a lot. Now let me walk you guys systematically through all the different things that I've been speaking about. Okay.
Awesome.
So first, let's start by going to my command prompt. Okay, wrong window. All right. So here's how I'm going to start this. I'm on my laptop. I have my server called pldemosql.database.windows.net. Let's see what happens when I do an NS lookup. As I showed you in the slides, right? I'm going to go to one of the public gateways, SQL gateways in the region, and I'm in a data slice. So my server is located in data slice 5, and then here's the traffic manager profile that is load balancing that. So that means that if traffic manager needs to load balance, this IP address will change. So I cannot just say, for example, put this in my host file and expect it to work all the time, right? So this is one thing that I want people to understand. Now let me see, for the purposes of the demo, I've kept it very simple. I'm just going to be using SQL CMD. I could use a GUI like Management Studio or ADS, but I just want to show you the error messages and how to resolve them. So SQL CMD, here we go. And all I'm doing here is trying to connect to the master database. So I got an error saying that the client with IP address so-and-so is not allowed access to the server. So when you get this error message, what this means is this is where the server level firewall rule is blocking you from connecting, right? And the error message is pretty, actually, it does give you what you need to do. Like you basically need to go to the portal and you need to add this IP address to the firewall rules, right? So let's go do exactly that. So here I am, I'm in my server, and you'll have to go to this firewalls and virtual networks blade. I'm going to say home, start and end IP will be the same. And actually, you can see here, it's actually detected my client IP
Nice.
address as well. So I hit save here, go back.
So now we're thinking you should be able to connect. Oh, there you go.
Yes, yeah. And then I can actually I'll just use a quick query to just show you that this is, so there's just a query against a DMV that enumerates the client IP address. So it does confirm that I'm connecting from my local box, right? So this is just a quick demo for how public connectivity works, right? Now, let me go here and talk a little bit more about what else we have here. So in this firewalls blade, I have set my minimum TLS version to 1.1, and my connection policy is set to default, which means now this connectivity from my laptop, since it is from outside Azure, it's going to use proxy. And I've set allow Azure services to no. Right? Now I just went in and created a server level firewall rule. So that's how we saw that public connectivity works. Now let me change the scenario a little bit, and let's move towards private connectivity, in which my demo SQL, this is in West US, and I have a client VM here that's in East US. And my aim is the same, right? I want this client VM to connect to my SQL server. Let's go look at some of the properties of the client VM. So when I look at the client VM, I see that it has this public IP address of 40.117.174.5. And it actually also has a private IP address that comes from this VNET and subnet. So what I've done is I've created a VNET here called demo VNET, and it has multiple subnets. So I have a subnet, like I showed you before. I have this giant VNet that I've cut or carved up into different subnets. So I've created a subnet that has all virtual machines called my VM subnet. And then I've created a subnet that will hold my private endpoints called PEC subnet. So that's the high level architecture of how I'm going to go about in this demo, okay? All right, so now let me RDP into the client machine. And what I'm showing you here is when I do an NS lookup for my server, I'm getting the exact same result, right? It's showing me I'm going to this public IP address. And then what happens when I do a SQL CMD is I get the exact same error message, which is this particular IP address needs to be added to the firewall rules. And why is it doing that? It's because I've not set up private connectivity yet. So that's why it's going to detect the public IP address uh, of my virtual machine. Okay. So here's where we will go ahead and actually set up private connectivity. And this is basically a demo of how we'll do that. So to do a private endpoint, my preferred way of doing it is go in the search bar in the portal and search for private link. It will put you here at the private links center. And what we want to do is actually create a new private endpoint. And I'll walk you through the process here. So first thing is it's asking me my resource group, which is where do I want this to be placed? And I want this in my same resource group that has my virtual machine in East US. And then I'm just going to name it, give it a name. So this is step one. Step two is all about, okay, what is the private link resource, right? So what is the PaaS service that I'm connecting to? So as I was telling you earlier, you can just see this list
Yeah,
is
wow.
huge, right? When we started about a year and a half back, it was just storage and SQL, and now you can see it's just growing. And even within SQL, there is like MySQL and others. So you have to be a bit careful on how you pick the right resource type here. And then I will my PL demo SQL. So this guy, right? And then my resource type is SQL Server. Click on configuration. Okay, now step two is I need to create what is the VNet and subnet I'm using. So as I showed you, is my PL demo VNet. And I don't want to create it in the same subnet as the virtual machine. I have a dedicated subnet for just for private endpoints, and I'm choosing that. The third option that you will typically need to choose here is, do you want to create a brand new private DNS zone? And that is usually what would be recommended. Here I've already created one in advance, so I'm just going to use that.
Hey, Rohit, quick question. On the subnet, you said you don't want to put it in the same subnet as your VM. Is there any reason for that?
No, it's just a network segmentation just to be different.
Keep
But
it
yeah,
separate.
we could actually keep it. Actually, that's a good point, right? We could keep it in the same VM subnet as well. And as long as, yeah, that would work as well. And now
Cool.
here I'm actually going to go ahead and kick off the create. So you actually can see what gets created behind the scenes. But while this is going on, were there any questions in the chat? Anything interesting that came up?
Yes, thanks for asking. So there were a few questions. One, I think someone was watching you use SQL CMD on your local laptop and were pretty
Mm-hmm.
interested by it. They asked if SQL CMD is kind of like a built-in package.
Yes, it is it is installed when you install. Typically, I get it by installing Management Studio, but I believe it's part of SQL client tools. So there you can actually go
Awesome.
ahead and just install that piece if you
Awesome.
want.
Cool. There were a few other questions about kind of like firewall rules and that sort of thing. The next question was, can we add IP ranges to allow virtual machines to access a database? So I think this was during the firewall rules section.
Absolutely. And that's what, so if you're not using private endpoints, then what you can do is add the public IP address of your virtual machine. Or if you want, if you know that all your virtual machines are in a specific subnet, then you can create what are called as VNET firewall rules to basically say, allow all my machines in this subnet to be able to connect to SQL database.
Awesome. Yeah, I find that one's really useful because if you have like dynamic IP addresses for your virtual machines, like it's just all in that VNet.
Yes, it's a
Okay,
one step gets it all done.
exactly. There was one more question if we
Sure.
have time. This person says, if I'm given the contributor role for a system assigned managed instance for my ADF pipeline and I put allow Azure services off, I think my ADF can still connect to Azure SQL Database. Am I correct?
Yes, so this is a slightly advanced topic of managed identity. So basically what managed identity does is it's an identity for a service or a resource in Azure. And using that, you can essentially bypass any firewalls. So yes, I believe this is how this scenario will work. Again, I've not played around with it in practice to give a definitive answer for sure.
Okay, cool. That's good to know. Thanks so much for answering these questions. Keep them coming,
Awesome.
viewers.
Awesome. Good question. So uh, I just finished deploying my private endpoint, and as you can see here, it took an IP address from this demo VNet and VM subnet. So now let's go back to the dashboard and actually see what got created, right? So in the same resource group as my VM, I now see a private endpoint. So we kind of knew that would happen. And then I actually see a NIC associated with it, right? So this is the private IP address. So as you can see, it got this IP address of 10.9.1.5, right? And then if I go back, the other interesting thing that gets created, if I here I had created it already, so I cheated, but otherwise, this is the third thing that will get created, which is this private DNS zone. And why this zone is interesting is it has this record that says PL demo SQL maps to 10.9.1.5, right? And this is what I was talking about, is this is the magic sauce behind the scenes that makes sure that when you're connecting from your VM, then you connect your connectivity, your connection string remains unchanged, and then you are connecting to this particular. So now I'll actually show that in practice. So let me get to the VM. Okay, let's do the same two commands. NS lookup. Now
Oh,
you see a difference here. It's going to this 10.9.1.5. So this is what the private DNS zone is doing. It's basically changing your DNS within the context of this VNet to be able to send traffic there, right? And now let's go look at what happens if I do this. Earlier, I was getting an error saying I need to add it to the firewall.
right.
Now I'm in, right? So there's no
Nice.
firewall involved, no nothing. I got kind of a shortcut connection to my database. Oh, okay, my bad. And it is showing me the IP config is 10.9.1.4. So this is the IP address of my VM. So
The
now when I'm,
private IP address, right?
yes, yes. So that's the key
Oh,
difference is everything now, when I'm connecting from this VM, I'm basically in the context, I'm in the context of this VNet, right? So there's no public connectivity option or anything like that going on, right? And then, so this is the key power of private connectivity and how you can do this, set it up for your resources in Azure. Now, let me go and try to close the loop on the server side, which is we go here under private. So under private endpoint connections, you'll actually see this private endpoint and it's approved. You can actually do a separation of duties here where the network admin creates this and then the SQL Server admin goes and approves. So that too is available. Here for the demo, I just did it all in one shot. Now, when I go back here, you'll now see that I get this option, right? Deny public network access. So I'm using private connectivity. I don't want anyone to connect via public. And you'll see the moment I flip this, you see how this got grayed out. And in
I
fact, we
see.
have a new UX landing soon that will make it more visible and in your face that, hey, once you flip this, right, then you are switching to private connectivity. So now let's see if I go to, so I know my VM is doing private connectivity. Let's see what happens when I try to connect from my laptop, for which I had added a firewall rule.
Right. And we're thinking we won't be able to connect.
Correct, because I basically said, don't allow anything to connect except a client that's using private connectivity. And here you'll get a different error message this time. It says, connection was denied since deny public network access is set to yes. So basically what it's telling me is, hey, you went ahead and basically said, don't allow any public connectivity to your SQL database. So that's what I've done. And that's why you're getting this error message.
Nice. This is actually a really useful error message. Sometimes they're very cryptic.
Yes. So that was kind of my demo. So let me switch back to the slides. Give me a minute to close some windows here. We don't need this.
Awesome. That was really interesting, Rohit. Really nice to see kind of like the full story from, hey, we're just getting started. What's kind of the easiest way to get connected all the way through. How do we set up like the most secure kind of connection? And, it kind of wraps up this nice story of what we have that exists today. I wonder, could you give us like any sort of sneak peeks as to what you guys are working on or what's coming next?
Absolutely. So this is the point of the show where we talk about future looking stuff. And, the first thing that we have here, we have named this feature Outbound Firewall Rules because we love firewall rules for some reason. But basic way I would pitch this feature to customers is, let's say you have a SQL database like this today, DB1 on the left, and it has network flows to these different storage accounts. Maybe it's writing a backup here or a audit log somewhere. And maybe you're using Elastic Query. So you go from DB1 to DB2 and DB3, right? And this is fairly normal for customers to have. What Outbound Firewall Rules gives you is sort of this bounding box to say, what are the resources that my database is allowed to send network traffic to, right? And why is this important? It's because this is a form of basically limiting network traffic, and it's a form of data exfiltration prevention. So that way you prevent movement of data outside of this bounding box. So you only interact with storage accounts or databases that you own or you have given permission to. And this is how you will give this permission is you'll basically at the server level, you'll set a high level property called restrict outbound network. When it's set to yes, that means you want to implement this bounding box, right? And then you will go add a list of allowed FQDNs, which is basically saying which are the resources that I'm allowing network flows to.
Oh, this is really interesting. I could see this being really useful. One thing I would wonder is, does separation of duties kind of play in here? Because if you're accessing the database, but you also have the ability to change this, like maybe there could be some, bad actors there, or how do you recommend implementing this, or still TBD?
Yeah, I mean, that's something that we're working on. For now, the feature is in private preview, and separation of duties is also something that's on our mind. But this is a very quick and dirty way to prevention capabilities. And then eventually what happens is just building this is not enough, right? I mean, we need to have features to be able to use this functionality. So we have these initial set of features, most of which interact with storage accounts. And then we have Elastic Query, which is the one SQL DB feature that will be using this pattern. But yeah, you're right. Separation of duties, and then also making sure that, today we are talking about Azure services. The scope could be increased to any outbound traffic through SQL database. So this is where the possibilities are limitless. But then this is kind of our way of providing this within the Azure SQL umbrella.
Cool, very cool. Hey, we did get a quick question about
Yes.
this. Someone asked, where would you put the outbound rule?
Yes. So that's a great question, right? I mean, this unfortunately is not something that you do in Azure networking. So it's not a NSG rule, or it is purely SQL Server based, right? And this again, as I said, it's in very early like private preview phases. And yes, at some point we'll look at how does this apply at a higher level.
Awesome.
And the other one feature that is on our radar is this IPv6 firewall rules. So the reason why we are doing this is very simple, right? Our customers are telling us, hey, we are out of IPv4 addresses. So IPv6 actually fixes this by, I mean, basically IPv4 was 4.3 billion IP addresses and we are all out of them. IPv6 just upped the game by just going like, I don't know.
And
Three,
undecillion? I'm not sure
yeah,
I've ever even seen that
it's a
word.
very big number that even with all the IoT devices, the mobile phones, what have you, we don't, based on what I've read, we shouldn't be hitting that limit anytime soon, but we'll see. That's what we know as of today, right? So now what are we doing from Azure SQL for this, right? We know that customers are used to the IPv4 firewall experience where you go click add IPv4 firewall. We'll do something similar or pretty much out of the gate. Our plan is to have complete parity with IPv4 firewall. So we're not changing much in terms of behavior. And then the key thing that we are working on is support for IPv6 in client drivers, right? Because it's no good giving IPv6 connectivity, but if you don't have the drivers to support it, then nobody
Right.
can connect. And then this is just a kind of my artist drawing of how we envision it to be, where at the server level, you'll go say, hey, I want to use IPv6 connectivity. You say yes, and then you go specify IPv6 ranges similar to how you would do IPv4 ranges today. Right?
Gotcha. That's really cool.
Yeah, and then I think now we are almost we're doing well on time, so I'll spend a little bit more time on this outbound firewall rule demo. So I'm going back to the question that we got, right? Where do you define this outbound firewall rule? So let me set up the demo first. Where did I lose my, yeah. Okay, so outbound firewall rules is purely an Azure SQL concept. So the way I'm going to demonstrate this is I have my SQL server and I have two storage account 1 and storage account 2. I go to my SQL server and say I want to use, let's pick auditing. Okay. So now what I do is I first go ahead and set this. I've already done this ahead of time, but I have enabled this outbound firewall rule uh, on my SQL Server by setting this restrict outbound network access property to enable. Okay, and then in my this second commandlet is how I'll enumerate what are the resources that I'm going to allow network traffic to. Right, there's nothing but enumerating the allowed list, and currently this list is empty. So here's what's going to happen. I'm going to say, let's pick demo storage account 2. I'm going to try and save auditing, and it should fail very quickly, hopefully here. You don't need that. But basically, the idea is I have a bounding box around my SQL server, and currently it's empty, right? So it's going to say not in the list, so it's not allowed. Now let me go add the storage account 2 into that bounding box. The way I do that is by using this commandlet called new AZ SQL Server outbound firewall rule. And you'll see in the allowed FQDN, I'm going to basically say demo storage account 2. And this is going to take about a couple of seconds here. But the basic idea is I'm basically saying now I want to allow network traffic from my server demo SQL to storage account 2, right? And I can confirm that by doing a get, which basically enumerates all the server level rules. I go back here. I still have storage account 2 selected. Click save. And it should save without any issues.
Because now you've enabled that kind of connection between the two.
Yes.
So
So what
you're
I'm
not
saying is,
only inbounding, like inbound, you have to have some rules so that the storage can connect, but outbound as well.
yes. So basically, the thing is that there are two aspects here, right? One is I'm basically saying, hey, allow network traffic to go from this particular SQL server to this storage account, right? Now on the storage side, I have to set up something else. I have to make sure that the firewall there is open, or I have to use managed identity, like the question asked by the one gentleman earlier on the call, right? So there's just one side of the story, but as you can see, it saved audit settings. And now let me just try to change. So let me try to use storage account one, which we know is not in the perimeter or the bounding box, and we should get the same error message again. Right. So this is again, I think we got good questions and thoughts around this. Again, we are in private preview, and there's a lot more fit and finish to be done to make this more usable. But this is just one quick demo of a feature that's using this. And as I said, you'll see this come up mainly for features that are interacting from one PaaS service to another. So for example, SQL talking to storage, or SQL talking to another SQL DB, and so on. So that was a quick demo for how this works. And I think we are almost on time.
Cool.
So
Yeah,
I
we've
can
gotten some
stop
great
here.
feedback across our channels. Someone said, great episode. So I think people are really enjoying this. I've learned a lot so far. So yeah, this has been a great episode.
I'm very happy to be here. Yeah, thank you.
Yeah, we're happy to have you, and thanks so much for, we got to see so much hands-on, which I feel like is really useful. It's great to get the theory, but then also great to kind of see it in practice, what it actually looks like and what those error messages actually look like. I think that was super useful. We take a look at what we've talked about, like what's next for the series, and what are some resources you have?
Yeah, so I think next would be, I think, data governance. And then we have these two other pillars on the side. And then in terms of resources, we have these aka.ms links. That's all about the pieces that we discuss. So people can look at these after the fact.
Awesome, cool. This has been really useful. I see it looks like people can dive into all the topics you talked about today. So definitely check that out. We'll be sure to put a link to all of these links. We'll be sure to put all these links in the description so you all can dive as deep as you want. If we talk about the rest of the series and you want to see the rest of the series, you can head over to that URL at the bottom there. We do have episodes 5 and 6 coming up down the schedule. I think data governance is scheduled for October, and the threat protection and detection is going to be scheduled later this year. I believe we're going to make it into December. It's been a really great series. Rohit, as we kind of wrap, do you have any advice for people who are maybe very new to this topic on how to get started or what they should consider?
Sure. I mean, at a high level, what I would say is understanding the connectivity architecture will go a long way in making your life easier as you adopt Azure SQL. For a lot of times, I've been on calls with customers where they have not understood the difference between redirection and proxy, and they're struggling to get their app going and connect to SQL database. And then, of course, we have things on the portal that will make life easier for you. But that would be my 2 cents, is just start from the basics and make sure you understand the trade-offs with each network access control or with connection policy, and you'll be off to a good start.
Awesome, great. Well, this has been super informational. I know I've learned a lot. I think our viewers have learned a lot from our comments and questions. We really hope this was useful. If you like this episode, go ahead and give this video a like, subscribe to our channel, and we hope to see you next time on Data Exposed.
Thank you.